So here in section 11.6, you'll notice we're obviously skipping here because we want to stay on the discussion of areas of polygons. And so we're going to look at finding areas of regular polygons here in 11.6. So first of all, the center of the polygon is the center of its circumscribed circle. Okay, the center of a polygon is pretty straightforward. It's the point that's directly in the middle. Okay. The radius of a polygon is the radius of its circumscribed circle. So in other words, really the other way of thinking about it is very simply the radius is the distance from the center point to any point or any vertex. Okay, so all of these here in this particular polygon would be called radiuses of the polygon. The apothem, which is something that's a little bit different here, the apothem of a polygon is the distance from the center to any side. Okay, remember, so to go from the center to the side, and it's got to be perpendicular to be the apothem. So this is also the apothem. All right, if it's a regular polygon, all of these apothems are going to be the same length. Okay. And then finally, the central angle of a regular polygon is an angle formed by two radii, okay, drawn to consecutive vertices. So a central angle here would be, let me get a different color here, I use green. This guy right here would be a central angle, okay. The distance from, just like this right here is a central angle. So the angle between two radii of one polygon. Alright, so in the diagram, it's a regular hexagon inscribed in circle G. Find each angle measure. So find the measure of angle EGF. Okay, EGF. Well, here's the deal you have to understand. It's a regular hexagon. So if I were to sketch in every single radius, it would be something like this. And so you'll notice then you have 1, 2, 3, 4, 5, 6 central angles. Okay, so each central angle is 360 divided by 6. So each central angle here is 60 degrees. So the measure of EGF, since it's just a central angle, is just 60 degrees. The measure of angle EGH, okay, EGH now, since it's the apothem, and these, do notice that all of these triangles are isosceles triangles. Okay, so when I drop down the apothem, it's going to bisect this side, and it's also going to bisect the central angle. So the measure of angle EGH here, let me erase all the hoopla now since I pretty much, there we go. The measure of angle EGH there is just going to be half of EGF, which is 30 degrees, and the measure of angle HEG, okay, should make sense that since this is a right triangle, if that guy's 90 and this guy's 30, this other angle over here has got to be 60 degrees. Okay. So again, just using some angle relationships there. In the diagram, FGHJ is a square inscribed in circle K. Find the measure of angle FKJ and the measure of angle KJF. So FKJ, again, that's a central angle. If I look at this, if I were to draw in all of my radii, I'd have 1, 2, 3, 4 central angles. So 360 divided by 4 tells me each central angle in a square is 90 degrees. Okay, so that means that FKJ, which is a central angle, is 90 degrees. Okay, KJF, now, again, let me erase all this. KJF is this angle right here. Okay, so angle KJF now, again, the idea is when you drop down this perpendicular line, this is a right angle. I bisect this angle up here, so if that whole angle was 90 like we already found out, then just this piece right here has to be 45. Alright, and so you have 45, 90, so this guy down here has got to be 45 degrees as well. Alright, again, just getting comfortable working with angle measures within a regular polygon. Alright, so here's the big thing from this section. It says the area of a regular polygon. Okay, the area of a regular n-gon with side length s is half the product of the apothem and the perimeter. Okay, so 1/2. All we're going to say is 1/2 a times p. Okay, that's it. You could also think of it as 1/2 times the apothem, and then the perimeter is just the number of sides times the side length. But again, my thing is I'll always resort to this formula right here, 1/2 AP, done. Okay, and then you understand how to find P. P is the perimeter, so you got to find the perimeter of the polygon, so on and so forth. Okay, so it says a wooden coaster is a regular octagon with 3 centimeter sides and a radius of about 3.92 centimeters. What is the area of the coaster? Okay, so again, identify your shape. It's not any of our special shapes. It's not a parallelogram. It's not a trapezoid. It's not any of those. So it's a regular polygon. So I have to use 1/2 little a capital P. Okay, so the first thing I have to find is, well, I can find either one really. The first thing I'll look for is, let's see if we can't find the perimeter. Perimeter should be pretty easy. Okay, let me use a different color here. P equals, each side is 3, and there are 1, 2, 3, 4, 5, 6, 7, 8 sides. We really already knew that because they tell you it's an octagon. So 3 times 8 is 24. So I've already gotten my P. I have 1/2 little a times 24. Okay, and now I got to find little a. Little a is going to be a little bit tougher to find. Okay, so here's what I do know. Okay, I do know that this side length right here is 3 units, and I also know that when I drop down this perpendicular, actually before I even do that, let's just find the measure of the central angle here. Okay, so this guy's 3. Let's find the measure of this angle right here. Okay, well, it's an octagon, so 360 divided by 8 angles tells you that each central angle here has to be 45 degrees. Okay, so that angle's 45 degrees. Now, understand this. When I drop down my perpendicular line, or my height, my apothem, right, when I draw in this apothem, that's got to be a right angle. Remember, this guy gets bisected, so each one's 1.5, and let me erase that 3 now. We don't need that 3 anymore. Okay, so each piece here is 1.5, and then remember this angle up here also gets bisected, so this piece of that angle is 22.5 degrees. Now, I'm going to redraw this triangle, okay, just so that you can kind of see what we're looking at. So what we have here is we have a triangle, okay, where we have a height drawn in, perpendicular. This is 1.5, this is 1.5, and this angle up here is 22.5 degrees. We know that this guy here is my A, my apothem. So I got to solve for A given that diagram. Good review, and unfortunately, well, maybe not unfortunately, but you have to solve for A here. Okay, and since all we know is this angle and one side, we're going to have to resort to SOHCAHTOA. Okay, so again, quick review. If this is my angle, the side I'm given is the opposite side. The side I'm trying to find is the adjacent side. If I'm using opposite adjacent, remember SOHCAHTOA, opposite adjacent tells me to use tan. Okay, so the way I'd set this thing up is I would say tan 22.5 equals 1.5 opposite over adjacent. Remember, over 1, cross multiply. I'm running out of some room here. Hopefully I gave you some more room on your notes than I gave myself here. And so as I work through this, I get A equals, I'm going to skip a couple steps, 1.5 divided by tan 22.5. And if I'm not mistaken, let me just grab my calculator real quick. So I have, let's see here. Alright, so we're looking at 1.5 divided by tangent 22.5, and if my calculator is correct, I get roughly 3.6. And so that's the guy that we're going to plug back up here into A. So the final thing I'm going to plug in is 1/2 3.6 times 24. And then when I plug all of that into my calculator again, excuse me, 0.5 times 3.6 times 24, I got 43.2 for my area, okay? 43.2 units squared, centimeters squared. Alright, so again, quite the process here for finding the area of a regular polygon, but nonetheless, something that you're going to have to be familiar with. So example 4, my suggestion would be just work through it on your own, see if you got it, and then play the video just to check it. Okay. So as I go through example 4 here, A equals, I'm going to try to condense some space here, 1/2 AP. I can find my perimeter, each side's 8. So if each side is 8, that means I have 1, 2, 3, 4, 5 of them. 8 times 5, P is 40. So I have 1/2 A times 40. Now I got to find A. Oftentimes what I'll do is I'll draw that in, but then I'll redraw that whole triangle. Okay, so in other words, I'll draw a triangle that looks like this, and I'll say, okay, this is 8, this is 6.8, and this is 6.8. Okay, I just took this triangle and I flipped it and drew it so it looks a little bit nicer. And so now what I can find is I can find this central angle measure, right? There's 5 of them, so 360 divided by 5. 360 divided by 5 is 72 degrees. Whoops, that was kind of crazy. 72 degrees for that central angle measure. So if that whole angle is 72, then when I draw in my height here, remember what that does now. We have 4 and 4, and since the whole angle is 72, just this guy right here would have to be 36. And so now what you're looking at is we have to solve for A, which is the height of this triangle. So I have this angle, and I can really use either one now because I know this side's 4, but I also know that the radius is 6.8. So you could use really sine, cosine, or tangent. Well, actually, sine's not going to help you. Cosine or tangent, either one's going to work. We'll just use tangent again. So this is my angle. 4 is opposite, A is adjacent. So tan 36 degrees equals opposite over adjacent. Cross multiply and solve. You're going to end up at A equals 4 divided by tan 36. And I'm just going to go ahead and plug that right into my calculator, and then we'll plug that back into the formula right away. So I have 4, let's see here, 4 divided by tan 36. I got 5.5. So really what I have now over here, so this thing is 5.5. So what I have is 1/2 of 5.5 times 40, not 20, 40. And so when I plug that into my calculator, I get 0.5 times 5.5 times 40, and I got 110. Okay, and obviously that's an estimate, that's not exact. 110 square inches for my area. Alright, so again, that's just the process for finding the area of a regular polygon. Alright, so that kind of wraps it up. We're going to keep the examples pretty straightforward. We're going to break this up in 2 days, and so we'll spend a lot of time the first day of just working on finding the apothem, reviewing SOHCAHTOA, and then the second day just more examples of finding actual areas of regular polygons. As always, bring questions to class, and we'll take those first thing.